Hello, folks, and welcome. Today we're going to be doing problem 661. This is moving into frames and machines. And so we're up till now, we've been looking at rigid bodies and primarily trusses or rigid bodies on their own. Now we're going to be looking at multiple rigid bodies that are connected together. That's really what frames and machines are. So in this problem, we see this is a pulley problem. I really like pulley problems. I think they can be a lot of fun. We're going to do this again in dynamics. But this one right here, we're asked to determine the force P that's required to hold this whole system in equilibrium. And so it's saying this mass here is 100 pounds. It's hanging by a rope, which is attached to pulley A. And so perhaps the first thing that we can notice from this problem is we've got one, two, three, four pulleys. But more importantly than the number of pulleys that we have is that each of these pulleys, not each of them, but there are unique ropes or unique cables that are in this problem. And we should know by now that if there's any type of cable, the tension in that cable is going to be the same anywhere along that cable. So here we've got a cable that starts at the roof, goes down, wraps around pulley A, and then goes up to B here. So the tension in this cable is going to be the same on both sides. Same with this cable that starts at the roof, goes down around B to pulley C. And then this third cable here, this is the interesting one where it starts at the roof, it goes down around pulley C, around pulley D, and then down here to this force P that's pulling on it. That means that that's the same force that's going to be here on pulley C, the same force in this cable throughout. So when we're going to work our way through and solve body by body, we're going to work our way through such that we can solve for P. Okay, so let's move along. I'm pretty sure this has got everything recorded, right? It's been a long time since I've recorded a video, so hopefully everything is going to work out here. Okay, so I've started setting up the problem here. This is going to be the same approach for any frame and machine problem. The first thing we want to do is we want to disassemble and draw the component parts. So right away, this is a brand new set that we haven't seen yet, but we want to draw all the parts independently such that we can, basically, we're investigating it piece by piece. We want to make sure we're applying appropriate labels to identify our knowns and our unknowns. This is going to be particularly important for any of the connection points between bodies. We want to make sure that we're representing that with the same label such that when we solve for one body, we'll then be able to apply that force to the body that it's connected to. And then finally, we're going to apply our equations of equilibrium. We're going to work through body by body, but we're going to start by a body that has three or less unknowns and one that has at least one known. So I'll demonstrate this as we go through this problem such that we can see that play out. So we've got this set up. We've got a bunch of pulleys in this case. And so I'm going to draw each pulley one at a time here and then go from there. So we're going to start with our free body diagrams. We're going to label the first one. In this case, it's fairly easy because these pulleys have labels. So I'm going to start with pulley A. I always have a hard time drawing circles freehand. So here's pulley A. Pulley A is connected to this weight. And this weight we know is 100 pounds. Pulley A has the tension of these ropes that go up like so. Or each of these is going to have a tension TA. Okay, so this is body A. We're going to work our way through and do this for the other ones. So for B, Draw my pulley. We know that B is connected. Let's only go back to this diagram here. We know that B is connected. It has this force acting down on it. This is going to be the tension in cable A. So we're going to be drawing that acting straight down. Oops. So this is going to be TA. Same thing with these two cables that act upwards. TB, TB. Now we're going to get to pulley C. Oh, that one's a little bit more janky. So pulley C has the tension of cable B. And then like we talked about right at the beginning, this cable that wraps around pulley B is the cable that eventually leads to that P force that we're trying to find. So we can put P up here. Now, just to make sure everything's all, we might be able to see from here that we're going to be able to work our way through and go A, B, C, and we're going to solve it right away at C. We only have one known, so we're going to have to start at A. That's kind of what we're going to have to do. But it's always good practice just to, draw out everything that we have here. So the last cable here, or last pulley, sorry, pulley D. Whoops, and I'm even drawing it wrong. Pulley D is actually attached to the roof with one cable like this that we can call force at D. And then it has the same tension P acting down on both sides. That up a bit. Okay, so with any of these frame and machine problems, we've now disassembled and drawn all of our component parts. Next step here, we need to apply our labels, identify knowns and unknowns. So we've done that. We've applied our labels such that this is what I said before is important. Our tension acting upwards at A here on pulley A is going to be acting downwards on pulley B. Similarly with tension B acting downwards on pulley C. So it's always good from here to go through and identify how many knowns and knowns we have from each of these. So for pulley A, we have one known, one unknown. For pulley B, we have two unknown. For pulley C, we have two unknown. And then for pulley D, we have two unknown. And so like we said up here, we have to start with one that has three or less unknowns. Well, all of them have three or less unknowns, but it also must have one or more knowns. This is the only thing we know is this 100 pounds. So we're going to start here. Okay, I'm going to slide this up. And we're going to do our equations of equilibrium. So we'll start with A And we're going to be defining positive upwards and look at the sum of forces in the y equals 0. For pulley A, we have 2TA pointing upwards minus 100 pounds. 2TA minus 100 pounds equals 0. TA is 50 pounds. Keep going. We'll look at pulley B. Pulley B, same thing, positive upwards. Sum of forces in the y equals 0. We have 2 TB minus TA equals 0. We found that TA is 50 pounds. 2 TB minus sub in 50 pounds equals 0. TB is 25 pounds. And then for pulley C, same thing. Equations of equilibrium, sum of forces in the y equals 0. We have 2p minus tb equals 0. So 2p minus sub in 25 pounds. Sub in 25 pounds equals 0. This gives us P is 12.5 pounds. That's our final answer. So when we look at this, I guess the other kind of interpretation, we see a pulley problem like this. For each of these pulleys, every time we step to another pulley, we're basically dividing that force in half. So we've got 100 pounds needs to be divided between these two pulleys. One of them's up here on the wall. That's going to take half of that weight. The rest of it's going to go to B. Same thing on this one. We're going to now have half of that weight pulling down. And now half of that new weight is going to be divided between the wall and the next pulley. So for each of these, we're reducing this, this force by a factor of 2. So we've got 100 divided by 2 is 50, divided by 2 is 25, divided by 2 is 12 and a half. And so this is a good example of looking at what we can call something like mechanical advantage. So if we need to lift this 100-pound block, we only have to apply 12 and a half pounds because most of that weight is being taken up by these other cables that are attached to the ceiling. And so we're able to pull down here and able to lift a much heavier weight than we'd be able to lift just on its own. So there's one last look at the solution. This approach will be the same for any frame and machine problem where we're going to break our broader system up into smaller free bodies and then solve from there. That's it for this problem.